All right, this is a video on dividing polynomials, and we'll do a brief review as way of introduction and then do a few different solved examples. So I want you to think back to maybe being in 4th grade, 5th grade, doing long division. And in this example we'll do today is 672 divided by 21. So as a reminder, first we thought, does 21 go into 6? No, it does not. Does 21 go into 67? Yes, it does. It goes in 3 times. 3 times 21 is 63, and we can subtract, and we have a 42 as our difference. Does 21 go into 42? It does. 2 times 21 is 42, and when we subtract, we get a 0, meaning our remainder is 0. So we have learned that 21 times 32 is 672. But we have also more generally learned that 21 is a factor of 672. And so much of what we're doing with polynomials and solving polynomials and graphing them is trying to find factors of them. So we will be doing that today, except rather than simply dividing numbers, we'll be dividing algebraic expressions. And it's not as hard as you might think. So as an example, which we won't solve today, but just as a way of showing you what we might look at, that's an example showing 6x squared plus 7x plus 2 divided by 2x plus 1. Okay, and so we could do some division. I hope you can imagine doing some division. And if the remainder is 0, then we know that 2x plus 1 is a factor of 6x squared plus 7x plus 2. So let's go ahead and try it with this example down below. So we are taking 4x squared plus 23x minus 16, and we are dividing it by x plus 5. Our first step here is to really just think about those couple terms, sort of the leading term of each expression. Okay? So I don't care about the 5 right now. I don't care about the 23x or the minus 16 right now. I just want to think about, does x go into evenly 4x squared? And it does. How many times does it go in? It goes in 4x times. Because when we then multiply and bring it down, 4x times x is a 4x squared. Okay? We also need to multiply the 4x by the 5. So we need to multiply these guys together. And that gives us a 20x. And then just like we did earlier with the simpler example, we can subtract. 4x squared minus 4x squared is 0, but 23x minus 20x is 3x minus 16. All right, so once again, we just need to think about, does this term evenly go into that term? And it does. How many times does x go into 3x? Well, 3 times. All right, and then we multiply back around. 3 times x is 3x. 3 times 5 is 15. And we subtract. 3x minus 3x is 0. A negative 16 minus 15 is a negative 31. The degree of negative 31 is lower than the degree of x. Okay? So what that means is that we're going to end up with a remainder. We can't say how many times does x plus 5 go into 31. That wouldn't really make a lot of sense to think about that. Okay, so our remainder is negative 31. So what that means really is that x plus 5 is not a factor of 4x squared plus 23x minus 16. It's always nice when you get a remainder of 0 because then you know what the factors are. But in this case, we are not being given a factor. So you can check some things as well. So in a related way, you can simply check to see if something's a factor by whether or not the remainder is 0. So think about, is 21 a factor of 670? Well, let's quickly do some division. How many times does 21 go into 670? It goes into 67 3 times. How many times does 21 go into 40? Once. And we have a remainder of 19. So no, since we do have a remainder, no, 21 is not a factor of 670. So let's check it out with this algebraic example that I'm giving you up above. So we will look at some, we will do some division here. And we need to divide 3x to the fourth minus 4x cubed plus 12x squared plus 5 by x squared plus 1. One hint I have for you is it looks like we're missing an x term, so I am going to put that x term in there, plus 0x plus 5, just to keep everything spaced out well. And reminder, we just care about the leading terms right now. So let's go ahead and think about how many times does x squared go into 3x to the fourth? That's 3x squared times. Multiply down and around. We have 3x to the fourth. And 3x squared times 1 is 3x squared. I'm going to place that under the x squared term to keep things lined up, so it'll be simple to combine like terms when we subtract. So I'm going to do a subtraction. And you could put in a 0x cubed here and fill in a 0x and a 0 if you want. It's not required, though. So I will actually erase those out of the way to keep things a little bit cleaner looking. And then we just subtract. Minus 4x cubed minus 0 is minus 4x cubed. Obviously, these two terms cancel out when we subtract, right? Plus a 9x squared plus 0x plus 5. Okay? So we're going to keep going. Think about the leading terms. Do the leading terms divide cleanly? And they do. X squared into a negative 4x cubed is a negative 4x. And when we multiply down around, we get a negative 4x cubed minus 4x. So that will be over under the x term. And once again, we subtract. Our initial terms cancel out. We have a 9x squared. 0x minus a negative 4x is a plus 4x plus 5. Again, just the leading terms. Does x squared go into 9x squared? It does. It goes in 9 times. And 9 times x squared is 9x squared. 9 times 1 is 9. We could subtract. And we are left with a 4x minus 4. The degree of what we are left with down here is a 1, which is lower than the degree of this x squared plus 1 expression up above. So we need to stop. We have a remainder, therefore, of 4x minus 4. All right? And that would be our solution to this division problem. Our solution is 3x squared minus 4x plus 9 with a remainder of 4x minus 4. Synthetic division is really just a shorthand, and if you have a printout showing this in a textbook or something, I would really encourage you to keep that as a reference. I'll certainly go through it right now. I think it might be easier to read a static copy or a static example that you can look at rather than necessarily watching a video, but I'll certainly go through it on video right now. You will take the coefficients, and making sure you don't miss any coefficients, you will write them out like this. You're going to, if we're dividing by x plus 2, you're going to flip the sign of the plus 2 and put it in a little box like that and show a little line down below, and this first 1 just comes down below. Okay? So that's how it's all set up. Hopefully it's clear that these terms match up, right? That's where those numbers came from. We will multiply the negative 2 times the 1 to get a negative 2. And then we will add down the columns, negative 16. Negative 2 times 16, negative 16, is 32. And then we will add down the columns to get an 83. Negative 2 times 83 is negative 166. And I need to add those together. We get a negative 220. And then we're done. We're done with that piece, though. Okay. This, we started out with a cubic term here. And so these are the coefficients in our quadratic quotient. And so we will write that out as x squared minus 16x plus 83. And this term at the end is our remainder. Okay, our remainder is negative 220. So this is our solution to the problem right here. The solution to this problem is right here, x squared minus 16x plus 83 with a remainder of negative 220. All right, as a last example here, one thing to know is using the remainder theorem, which I will read to you and you should access in a textbook as well. But the remainder theorem says that if we divide a polynomial by x minus a, then the remainder that we get is the value of the polynomial when it's evaluated at a. So in other words, what that means is if we can divide this polynomial here, if we can divide it by x minus 3, the remainder that we get is the value of the polynomial if we were to plug 3 in for x. In other words, that's what p of 3 is, plugging 3 in, evaluating my polynomial at 3. In many cases, this it would be more efficient, certainly quicker to simply plug in 3. But I hope you can imagine that this might be a way of perhaps programming a computer to evaluate a polynomial. It might be more efficient from a processing perspective. So let's set up our division. So we are really dividing, once again, by x minus 3. We're dividing by x minus 3. Okay, so we're going to flip the sign of that 3. Let's do some synthetic division here. We have a 1x to the 5th, a 0x to the 4th, a negative 2x cubed, a negative 1x squared, a 0x, and a 2. We're going to draw our horizontal line, bring down the 1. Okay, so again, we're following that synthetic division process, sort of a zigzag process where we multiply and bring the term up to there, and then we will add the columns together. What you want to remember, which is easy to forget around synthetic division, is these numbers you will be adding together to get the number down below. Let me clean up my board a little bit here, and we can get going. 3 times 1 is a 3. Add down the column, we get a 3. 3 times a 3 is a 9. Add down the column, we get a 7. 3 times a 7 is a 21. Add down the column, we get a 20, 60, 180, and then 182. Okay? So all we really need, though, is this term right here, the remainder term, and so that's our solution. Okay? P of 3, then, is 182. And I'm certain that you could check that on your own as an exercise on your own, that if we were to evaluate this function by plugging in a 3 for each of those x terms, we'd get a 182. That's a great place to stop right there.